We're going to go over the product and chain rules for derivatives, okay? So they're both written out here. Our product rule, if we have a function multiplied by another function, then the derivative of the larger function is equal to the derivative of our first function multiplied by the original plus the derivative of the second function multiplied by the original of the first function. Okay? And again, that'll make more sense when we have a question that's all set up like this. And a power of a function rule, if we have a function within an exponent, we still use our power rule we learned in the last lesson where we bring our exponent value down in front and the power on top we subtract by a value of 1. But we'll also be multiplying that by the derivative of the function within the brackets. Okay? And we actually did that in the last chapter. We just didn't really talk about it. For instance, if I have x to the power of 3, using this same power of a function rule, we bring the 3 down and we subtract it. We get power of 2. And technically, derivative of x, what would the derivative of x be? 1. Okay? Well, instead of doing that part, we know that when we multiply anything by 1, we're just going to end up with 3x squared. It's when we get a larger type function with 2, so something like a binomial or a trinomial within the exponent, that we really have to keep this in mind when going through it. Okay? Oh, I didn't write out an example. That's okay. Let's just make one up. So, 3x plus 5, 4x minus 2. Okay? So we're going to derive this function here using our product rule. So the derivative, or f prime x, is equal to, imagine this being, and I know they use different letters up there, but h at x, and this is our g at x. Okay. So what they're looking for in this is they're going to be looking for h prime x, so I have to find the derivative of the first bracket, multiplied by g at x, so I leave the second bracket the same as is, plus the original of h x multiplied by the prime, so g prime x, so the derivative of the second function. So let's keep that in mind as we go through this. We're going to derive the first one, and when I derive this, imagine this like a 1, so we bring 1 down, we get 3. What happens to our x here? Disappears because what does this exponent become? 0. So 0 turns the variable into the value of 1. 1 times 3 is just 3. And what is the derivative of any constant value? 0. So 3 plus 0 is 3. Good. So the derivative of our first bracket is just the value of 3. And then we rewrite the second bracket beside it, 4x subtract 2. Plus, again, let's rewrite the first bracket the same as it was, 3x plus 5. And let's talk about deriving the second one. It'll be very similar. This is to the power of 1. Bring 1 down, 1 times 4 is 4. The x becomes the value of 1. And the negative 2 becomes 0, so our derivative of that is just the value of 4. So you can leave it like this. This is technically the derivative. But maybe you want to simplify it a little farther. We would use our distributive property, bring our 3 in. So I'd end up with 12x minus 6 plus 12x plus 20. Which means I then have our x's cancel out. What happened there? Oh yeah, sorry. Double, thank you. 24x plus 14. Okay? So this is a more simplified version of this derivative here. Both are equivalent. You just might have different answers written different ways on tests, so keep that in mind that you can simplify or expand things farther. Okay? Let's do a chain rule. Chain rule, let's say we have 3x power 4 minus 2x plus 3 to the power of 4. So here is our original function. We want to derive this. So when we go to derive this, we have f prime x is equal to, and remember, the way we go about doing this, assuming this is our g at x, okay, and it was to the power of n. When we go to derive it, we have n in front of our g at x. G at x being the exact same as it was before, and subtract 1, all multiplied by the derivative of g at x. Okay. So we leave this as is the start. We go to take this down. Our 4 will come down in front, so we have 4 as our n. In our bracket, 3x to the power 4 minus 2x plus 3. Our exponent then goes down a value to 3. But then we multiply that by the derivative of our g at x. So we go to derive inside the function. Okay, so we bring the 4 down. This becomes 12x to the power of 3. The 1 comes down, which will give us negative 2, and the 3 becomes the value of 0. So this is now the derivative of our function 4 multiplied by 3x to the power 4 minus 2x plus 3 cubed times 12x cubed minus 2. Now, it's not wrong to expand this. We could expand this. It would just take a really long time. So normally we would keep this in this version. This is almost like a factored version, a simplified version to look at. But if you get a set of answers on a test and they're all expanded, you might need to expand this to make sure you get it. Yeah? Yeah, you could. That would be expanded. It's the exact same idea.